that they allow us to use, and the Fachhochschulen and different schools and research institute of Switzerland. So we're really happy that so many people support this type of project where data is in the center and collaboration is the movement behind innovation. I will quickly pass the word to Peter with the Hightech Zentrum.
Okay, yeah, thank you. Also from my side, I would like to say hello to everyone. I'm really happy to see so many faces attending this venue today. So yeah, I was asked, let's say half an hour ago to say a few words more than just an introduction. So I have added some slides into my presentation. I want to say hello from the Hightech Zentrum Aargau. We are an organization in the canton who was built to foster innovation, technology innovation in the canton of Aargau. So we work closely together with companies in the canton of Aargau, and here I would say mostly of the energy sector is located in the Aargau in Switzerland. So that's why the center, the Hightech Zentrum, has also some strong activities in the energy technology and resource efficiency sector. And I'm heading this section of the Hightech Zentrum. And hello to everyone. It's also nice to have you here in the Technopark. I also should say hello from the Technopark side. So as we occupy ourselves mostly with innovation and technology innovation, I want to go ahead and say a few words about how technology is adopted and or how technology innovation is going on. And I don't want to go too much into details because we will have an input referent from the ETH a few minutes later. So here I just want to say how technology adoption is usually going on is in a very steep S-curve. This is an adoption curve which usually is not really reflected by, let's say, technology analysts, because usually you think that technology is adopted in a linear way and very smoothly. So this is always happening very rapid, and you can also see that also the phone during the war or the recession period had a little drop, but then it was going on. And what you can see is that the innovation curve, the adoption curve, is always becoming steeper in the close past, and it's also that you can see that mobile phones, computer, etc., was adopted very fast. When you look at cars, and this is what happened in the past, in the beginning of the 19th century, this was the Fifth Avenue in New York. These are all horse cars or horse driven by vehicles, so to say. And here was just one internal combustion engine running. This was 1900, 1913. You can see all the cars have been moved by gasoline, and only one horse was there. So this changed just in 13 years. And this is very fast. And you can see it on this curve, how fast it actually was. And you can see that from 10% to 80%, this is happening in 10 years. And what I want to say is that this is also happening in other sectors. So we have changes ahead on a global scale. And this is something that we have to keep in mind, that why do we work in energy and why do we want to have the energy transition? It's because of climate change. So when you look at the temperature rising curve, when you would take into account that there is only natural factors playing a role, then you see that the temperature curve would have been flat. And when you introduce human activities into the models, then you see this is exactly what's going to happen. So humans are the cause of global warming. You see global warming is taking is around 1 degree Celsius today. In Switzerland, we have almost the doubled temperature rise because we have also cold regions in the mountains, and in cold regions it's changing faster. So why is it so dangerous? Oh, you see, I was fast in putting all things together, but this is I just want to mention one thing, and this is the melting of the Arctic region. Because in the discussion about global warming, always 2 degrees Celsius was mentioned, and this would be here. And what one realized during the last 10 or 15 years was when we would reach 2 degrees, then the melting of the Arctic would be sure. So when we move down to 1.5 degrees, there is a tiny possibility that the Arctics are not completely melting, but probably we're too slow. But this is one of the main driving motivational drivers, at least for me, to work for the energy transition. So what we have ahead of us is when we would like to be sure to be below 1.5 degrees, we should not go over 600 gigatons of CO2 emission total, or from when the study went out, it was 2016, and 800 gigatons would, could also lead to below 1.5, but it's not so sure. So that means we have to decarbonize very steep. So this is just something that we have to have in mind. So going back to cars and digitalization, we see that there is a lot is going on. So self-driving cars probably are coming faster than we think. We have many companies which are working in this field. I'm sorry for the fonts, which are not running well on this computer, but okay. But just to say that digitalization is also playing a role today in cars, and very heavy so. Volkswagen changed the entire strategy of their car fleets and how they would like to go on in the future. So digitalization is clear, is self-driving main driver, but also sharing economy is enabled by digitalization and the digital tools that we all have in our pockets today. When we look, change it in colors as well. So when we look at the energy system, which was let's say in Switzerland, hydropower, so there would be blue and rocky colors, but okay, you can imagine what this picture should be. So we were mainly heating with oil and also driving with oil. We had electricity from the hydropower plants, and gas was coming into were also coming in. So today we have more heating by heat pumps and photovoltaics, and this is going on. And cars are coming into play, probably vehicle to grid, we don't know, but probably this is coming. We have storage systems which are stabilizing the whole system. And in the end, there was also a building built in Brütten in the canton of Zurich. It's a building which is completely autark. So everything, all the energy is coming in by PV or building integrated PV and stored in hydrogen, hot water, and also battery. And for sure, also the thermal energy is coming from the ground. So this is the future system. And behind of that, we have digitalization as a driver, which is connecting all these different sectors. We have renewable energies, we have buildings, vehicles, mobility, batteries, and the smart grid, all in total. When we look at the future, we could have systems which are completely autark. We can also think of a global grid. This is from a Chinese book, which I found let's say the idea that everything is connected, and you could say that the sun is shining always somewhere, and wind is also blowing somewhere, and waves are also somewhere on the oceans. But I'm sure that the future is somehow in the middle. So we will have connected systems, we will have smart cities, and we will have renewable regions which are completely driven by renewable energy. And digitalization is playing a very, very strong mover or enabler in this field. And innovation and digitalization and energy is something which you are now working in the next 2 days, and I'm very happy to have you here. Thank you.
So, sorry, yeah, I just wanted to shortly present the program of today. So we're welcoming you and having a few keynote speeches and presentations. Then we will present the challenges. Then after we present the challenges, you will build your groups, choose towards which challenge you're most interested to get to, and build those groups. Then you will we will have lunch after 1 hour or something into you being a group. There will be a short introduction of Oleg about the whole technical infrastructure. And then it will go on until we present tomorrow at 3 o'clock the results, your prototypes and your pitches. So I will quickly give the floor back to the next presentation of Mark. Of Marius Schwarz, who is a researcher at the ETH. He focuses actually on the interaction between innovation and technology, so and the fusion of technology, as Peter was already a bit mentioning.
Perfect. Good morning, everybody, also from my side. And also thank you a lot for the kind introduction. So I am an energy system modeler. So during my PhD at the ETH Zurich, I developed agent-based models to test the impact of policies on the adoption and diffusion of technologies. For example, in one project, I assessed the effectiveness of financial subsidies to accelerate the adoption of solar power by Californian households. At the Energy Science Center, I'm leading a project in which we model the Swiss power system, using energy system and economic models, a collaboration effort of 4 different professorships. In all modeling projects, I realized that energy data, first, is becoming increasingly important, and second, that its use is still very challenging. Let's first shed some light on why energy data is becoming increasingly important. While the Swiss energy landscape has always been changing, for example, the skyrocketing demand after the Second World War, or the rise and fall of petroleum fuels, the ongoing digitalization, decentralization, and decarbonization impose unique challenges to all actors involved. The future of the Swiss energy sector is shaped by the Swiss Energy Strategy 2050, which aims at increasing energy efficiency, accelerating the deployment of renewable energies, and phasing out nuclear power plants. In addition, the electrification of vehicles, buildings, and industry allows for further decarbonization of the energy sector by switching from carbon-heavy energy carriers to potentially carbon-neutral electricity. The increasing share of variable renewable energies and the additional loads through building and vehicle electrification are likely to challenge grid operators to continue the matching of electricity supply and demand. But they're a promising solution, and we heard of a couple of them in the previous talk. Battery storage can store excess PV electricity during the day and provide electricity during the sunset. Controlled charging of electric vehicles can not only mitigate the adverse effects of the immense charging load, but might even leverage electric vehicles to integrate higher shares of renewable energies. Virtual storages that connect hundreds or thousands of these technologies can become essential market players providing grid services. However, the future of the Swiss power systems remain unclear. Will renewables be able to substitute nuclear power and simultaneously cover the additional demand due to electrification? Which technologies will address the daily fluctuations and seasonal patterns of renewable power generation? To answer these questions, we started the Nexus E project at the Energy Science Center at the ETH Zurich. Nexus E is a modeling platform to create scenarios for the future of the Swiss power system. The platform represents Switzerland's power system in detail, for example, the transmission grid, which you can see here on this slide. However, representing a power system on a national level requires a large amount of energy data. Although we use Nexus E to create scenarios for the future, historical data is essential. To increase trust in our model, we use historical input data and compare the resulting outputs to real-world data to judge the correspondence with reality. This is what we call model validation, and it's best practice in the modeling community. Without a good fit with historical data, the simulated scenarios are unusable. During the development of the Nexus E platform, but also developing the previous agent-based models, I came across 3 challenges for using energy data. First, the data simply do not exist. Energy data, in particular on the consumer level, such as electricity demand of individual buildings, is limited, mostly due to a lack of smart meter devices. However, the 2018 update of the Swiss energy law requires a share of smart meters of 80% by 2027. Second, the use of available data was restricted. So thanks to the data provided by Swissgrid, we were able to model the transmission system in detail. However, as it is sensitive data, its use was restricted. This is problematic with the transparency and reproducibility principles of Nexus E in particular, but academic research in general. Third, the data was available, but only decentralized. Available energy data for the Swiss power system is spread across multiple sources, although BFE is already collecting and providing a large amount of data. This results in inefficiency and increasing costs for all researchers. A promising solution are centralized data hubs and exchange tools. Data hubs are now almost standard in Europe, but the design varies greatly from country to country, mostly for the degree of centralization. One success story for open data and data hubs in particular is Estland. Estland created the data hub S-Feed, which connects the needs of consumers, so the data owners, energy service providers, the data users, and meter data hubs, so the data providers. Generating data on consumption, production, and transmission helped Estland to systematically increase the efficiency and reliability of the energy system. The data hub is open to third parties to develop new business models and services. For this to happen, Estland achieved already 100% coverage of smart meters in offices and households already back in 2014. Key to the success is a user interface to customers, which allows them to grant third-party access to personal energy metering data. To conclude, from an energy modeling perspective at least, the availability of easy-to-access energy data is already crucial today and becomes more and more important with the ongoing decentralization and decarbonization of the energy system. My key takeaways are: generate more energy data, and I think for this the rollout of smart metering devices will help. Concentrate energy data in hubs and data exchange tools, and make energy data open access. So if the data owner grants the access. So that's it from my side. Thank you very much for your attention.
So I am going to present Open Data a little bit. Who of you has been to an Open Data event already? like 1/3, let's say. So we are an association. We are part of the network of the Open Knowledge Network, and we are the Swiss chair of Open Data. And our mission is to make data public, in order to allow transparency, allow to order innovation, and to allow Mitwirkung, to allow collaboration. Thank you. Well, in my hair, I don't know if it's going to work. Does it work?
No, it does not. Just hang this on your ears.
Yeah, sorry. There are so many things on my ears.
You need to lift behind your ear, your hair.
Okay. So maybe I'll manage.
I give this. It's not too bad, I guess, and I give some sound to you.
So now I really look like a cyborg.
No. So is it hanging?
No, it's already hanging. Yeah, here.
So let's try. Please talk something.
Yeah, sorry. Yeah, it sounds as if it's working. So Open Data is trying to promote this idea of opening data sets within the protection of privacy of the individuals. And that's one of the big challenges, as you probably all know. But the key features of openness are the availability, the accessibility, that it's possible to have it for very little money or even free, the possibility to reuse and redistribute the information, including the capacity of machine reading the information, and the standardization of the metadata around the data. So what kind of format, what kind of licensing, etc., that's around the data. And that's that the participation around this data is broad. So of course, universal participation is the goal, but everyone should be able to use and reuse, redistribute the information, which is not sensible private data, but which is data that we can use for innovation and the common good. We are taking part, or we are initiating many different types of activities. The hackathons are one of the activities that we're supporting. We do that because we think it's the chance to for everybody to realize that even a proprietary data set, when you open it a little bit for a little time and you start to collaborate together, you will actually come to results that you didn't expect or that wouldn't have happened without this opening. Very often it's also about crossing the information from different data sets, and that's when the innovation comes, not only with data, but in general. As soon as one crosses two ideas, then innovation comes. But some of the things we do is the School of Data. We want to support this more, to have a better understanding in the general public of what is data and how can we diffuse data better. We have some vulgarization, let's say, or sensibilization projects like the Data Cafe that we started this summer, where it's about exchanging coffee against few information, and people start realizing that they don't want to give their information for the price of a coffee, and forget a bit that they do that all the time. We have a project that we started this year, which is the Prototype Fund, which is supported, also the Data Cafe is also supported by the Mercator Stiftung. And with this Prototype Fund, we are supporting projects that are trying to develop digitalization and democracy. than the Hackdays, as you know. And we have actually working groups that are very often the result of the Hackdays. So maybe you have heard of the Energy Working Group that actually started from the Hackdays, the Energy Hackdays 2019, and which gathers many of the actors of the energy sector, and they meet regularly and try to figure out synergies. And some of you are actually here in the room. And we also actually try to make some lobbying and support our vision about a world where data is a common good, and administrations and organizations try their best to share the potential, the part of the information that has the most potential, and not only to zukleben us with publicity. So if you want to support our activities, become a member. We would be very happy. So the hackathons, what are they? So it's all of you, it's experts, and from very different fields. We do not expect anybody to be not everybody has to be a programmer. We're happy when there are some, but we do not expect anybody to be the super expert. It's always interesting to have the different views of the people. It's open data and it's ideas that come from the mix. Then we have the challenges that are actually coming from challenge owners, we call them, or ideators. Sometimes it comes from companies that identify a problem, an issue. Sometimes it comes from the schools or the research institutes. And it might also come from the civil society. And when you build the teams, you're free to choose the challenge and to group with anybody you want. And you're also free to change during the event, even if it doesn't fit. And it's about hacking, so this brainstorming, which ends up in a prototype. And then we present the results and discuss them in the best case after the presentation, and hopefully some of the projects are gonna sparkle the idea of a company maybe, or are going to enter in a discussion with the challenge owner and are going to be supported for further developments. So this is what we hope for. And this is, for example, one of the results of last year that we really liked. What is what? It's going to be actually one of the challenges is building also on this start. And what we like also is that it's really neatly presented, and it also showcases what we can realize in 2 days. Sometimes it's a bit less, sometimes it's a bit more, but this showcases that very well. During the hackathon, what you find interesting is to have this brainstorming and to discuss and to program and to make prototypes. And what one doesn't like so much is to document the projects. But it's very important for us that you document the projects, not only because we like it, but also because we can keep track of what happened. We can build on the information that you gathered, and not only us, but also everybody else who is interested in the topic. So it's extremely important, not only as a benchmark, but really as building a common knowledge and building this corpus of data about energy. It's not yet a data hub, but it's a kind of hub of ideas around energy. So you already have made a drip data account. It's our interface to document the projects. If you haven't and you have problems or don't really get ask our Oleg. And then you create from the interface where you see the events, the challenges. You will create a new project for the group, and then you'll document within this this interface at the end or during the process. You can synchronize it with programming platform like GitHub and everything, but this you will know even better than I. And feel free to use Slack. Each project has, or each challenge at least has a Slack channel. We can create new ones if you need. So to start the discussion, and maybe you can follow several, and maybe you have insights or ideas about other challenges. So of course you can use other tools. And we would like you to get a pitch and a simple poster ready for Saturday at 3 o'clock. This simple poster is really just a flip chart page where you write what you find relevant. But the idea is to gather comments and ideas, contacts, suggestions from the group for your project after you've been pitching, because there are so many competencies and so many ideas and such a great network. There would be a pity not to gather this information after you've heard the pitches and probably it sparkled ideas. So we are happy if you follow those guidelines for the documentation. It's nothing miraculous, but it's just remembering what are the important things that should be informed. And this is the platform that you might have seen already. And quickly here, to get started, you click there and then you have a little explanation of how it goes. So another few organizational informations about the Hightech Zentrum and how it's gonna go these 2 days. So where is what? So we are presently here. So I'm standing here. And these clouds are actually the places where you can hack. So we're going to take the tables out and reorganize the whole room. I don't remember how many tables are planned here, but you can count. And here should be, well, it's a bit different. So we have wait a minute, we have here the fridge, and the food is a bit spread, but you can find. And the coffee machine. For the coffee machine, maybe you all have discovered already that the little capsules are in the box. And of course, our Oleg is here, so behind there. And here you will find everything technical, well, also love, but all what's about data you will find there. And another, so this is the second, well, the ground floor actually, but for us the first floor. And there are 2 meeting rooms that we can use here and there, and the co-working space that we can also use. And we have planned that, yeah, 2 groups each, and then here 3 groups could work. And it's also there that if somebody has to roll out a mattress, it's probably going to happen there. There should be a little bit of food up here, but I don't know if it's really the case. Will be placed during lunchtime. For lunchtime. So, COVID, wash your hands, refrain from shaking hands, wear a mask if possible. I mean, all of the high schools and research institutes that take part actually have a mask Pflicht, obligatorium. So maybe it's a good idea. I mean, we would feel really bad if it would end up in a super spreader event. And of course, if you feel bad or sick, work from home. So in case anybody sneezes, there are 3 ways out. So around next to the lift and somewhere here behind the, where it's hidden, there would be an exit, emergency exit. So it's not really supposed to go like that, but. And we have a small medical kit and defibrillator in the 2nd floor if the challenges are too stressful. So yeah, the guidelines of the of a hackathon, maybe you already know a bit, but it's about we're in a safe place and we want to enjoy each other and no stress and just happiness.
Will you contribute to my happiness by reminding me of the Wi-Fi password, please?
The Wi-Fi it's coming. So the food, very important. And then just after the food, so the password of the Wi-Fi is the same as the Wi-Fi name, and it's Opendata.ch. But you see, I thought it's exactly as important as the food. So the Slack is I think everybody has. Yeah, if you need support for the Slack, go ahead, and you should find everything here. So now we're gonna start with the challenges. So Jonas is here. Am I especially leise, or should I?
I think it's okay. I can manage. Genau.
Das war einfach, es gehört wirklich die Leute frisch dahinter gestanden. Und es gehört das schon hin. Ich gehe jetzt kurz.
Das ist einfach eben.
So, einfach so halten.
Okay, so everybody can hear me now, I guess. Good morning, also from my side. My name is Jonas. I work for Open Energy AG, and it's my pleasure to open this pitching session by presenting our 2 challenges. The first one is about district heating optimization. So I think as these are energy hack days, it's more than fair to also consider heating, because heating accounts for a huge share of energy consumption in Switzerland and for an even higher share of the CO2 emissions because of the still many legacy furnaces that rely on fossil fuels. So district heating is a means to deploy renewable heating on scale, because all of our district heating networks, they create the heat either by burning biomass or by using waste heat through heat pumps that can be driven by renewable electricity. I mean, I already mentioned it. You probably know IW Energie mainly as the main distribution grid operator in the canton of Aargau, but we are also quite active in district heating. What we challenge you in this challenge is to help us optimize the operation of our district heating networks even further, such that we can further minimize and reduce the usage of primary energy that goes into these heating networks. To do so, it would be very helpful to have accurate load forecasts based on the historical measurement data that we collect in all these networks, for example, combined with using weather information. It's about optimizing the usage of peak load furnaces, for example, through improving the load scheduling inside the district heating network. We provide you with a quite large data set covering 2 years of operation in 5-minute resolution of one of our district heating networks. So it's all kind of measurements from powers, energies, flow rates, whatever you can kind of dream of to work with. If you have any further ideas what you would like to do with that data, maybe you have some completely different creative ideas that I did not come up with so far, feel free to do so. Feel free to talk to us. We are really interested in your ideas and in the results that maybe evolve out of this challenge. This brings me over to the second challenge. This is also about optimization. It's about solar PV optimization, especially the optimization of self-consumption in buildings where you have a large PV plant on top. Think a school, think warehouses, think industrial buildings. And there it's about identifying a systematic potential for optimization. To illustrate this point a bit further, I've put this illustration of this example on the slide where you can see that during the days, the PV plant generates quite a lot of power, almost all of which is fed back to the grid. But then as soon as the sun goes down, you see the red curve, which is the load in the building, shows a peak, and this repeats day after day after day. So of course, it would be very nice if you could move this peak during the daytime, if at all possible, such that you could feed this local load with the energy you generate locally. To do so, you could use load management if possible. You could add storage if it is feasible cost-wise, and if you have storage, you want to design it optimally in terms of energy storage capacity, but also in terms of power capability, depending on the load and the PV plant. So what we would like to achieve with this challenge is to have maybe some kind of tool or some other means that can quickly process a time series of measurement data of load and generation of such a facility, and then points to where this potential lies to improve the self-consumption systematically throughout the year. Again, provide a data set with measurements covering 1 year in 50-minute resolution for 3 such larger PV plants that we own. And again, if you have further ideas what to do with the data, feel free. We're really curious about your ideas and about the projects that may evolve out of those 2 challenges. With that said, I'm looking forward to these hackathons and have fun.
You need this? Or is it loud enough to try?
No, it's not.
Not loud enough.
It's not loud enough.
Are you
Or
sure?
you have to scream.
I can do that.
You can do that. Nobody will listen.
All right. Good morning. Excited to be here. Contrary to the statement of Peter in the very early in the morning, there is energy stuff happening outside of Aargau. So IKZ is one of the largest Swiss utilities from the canton of Zurich. Can you hear? Okay, so you can see me. All right. I'll stand behind the podium. And the first challenge that I want to introduce is related to that lack of transparency and missing data or non-existing data on the energy consumption side. So we're a bit more aggressive than legally required, and we aim to be finished by the end of 2024 with more than 400,000 smart meters. That makes us the largest operator of a smart metering fleet in Switzerland. Nobody has more end customers. And today we have roughly about 200,000 of those smart meters. Now, these smart meters have an interface for the customer, but it's not so straightforward to use. And this is our first challenge. We would like you to help us. Okay, there's many things to look at. We would like you to help us to enable the customer to use this interface. So this is a demanding challenge in using hardware and software. We brought a Raspberry Pi, some interface software to directly talk to a smart meter. You can look at it, it's there in the back on the floor. You can plug something in, maybe connect the coffee machine and see the consumption through this local interface. Now, the idea of this challenge, these 2 days, is just to create a working real-time visualization. And this would then allow us to put on our website a community, a maker instruction, so to speak, for our customers to do such a real-time visualization of their own data themselves. Now, if this is not challenging enough for you, if you can get out all the proprietary software that is in this interface in these 2 days, please don't only brush up the interface and design it well, also brush up your CV and send me an email and we talk about your professional future. With that, join this challenge, very important, very relevant. With that, I'll pass it on to my next IKZ colleague, and he will talk about electric vehicles. Angelos?
Can you hear me? Yes. Okay. The next challenge is about electric vehicles and electric mobility. It's called cheapest charging around. So Imagine you have an electric car and you're on your way and you want to find a charging station, a public charging station, to charge your car. You have to go on the internet and you have to find the closest charging station that is around you. And the Swiss Federal Office of Energy has been kind enough to create such a web page, ichtankestrom.ch. You can see here the web page on a mobile phone, where they have aggregated all the data of the different charging operators of charging stations. And there you can go and find the closest charging station. But this website is missing one very important thing, and this is pricing. And pricing is very important for one reason. The different companies, they install their charging stations, the public charging stations, and their subscribers, they can go to the charging station and charge their cars with a certain price. Now, in order to increase the efficiency of the investment of this infrastructure, of course, these companies, they let subscribers of other companies use their charging stations. So we have a situation where we have one charging station and different prices according to whether you are a subscriber of the one company or the other. And but you cannot find a place like this website where you can have all the data. And this is exactly the challenge. We want to have an interface where we can have all the pricing data so that a person can go online and find the closest but also the cheapest charging station according to their subscriptions. And this is very important because there are actually the prices are not very transparent right now. So we want to increase the market efficiency and we want to help people avoid extreme charges. Yeah. Thank you very much. Now my colleague Martin.
Okay. Hi, everyone. So I'm also excited to be here, and we just go on with the topic immobility. I present you a different challenge, but we use some of the same data at least. So we are interested in the behavior of immobility drivers and the cars, and we have a lot of data to actually do an investigation there. We did some web scraping. We saved the data from ichtankestrom.ch. That was the website that Angelos just presented to you for 6 months, from February until now. It doesn't give us much data, but it does give us the status of each connector that is on that website. So whether it is free, occupied, or out of order. And there, of course, we would like to have an investigation, know what charging station is used often, what charging station is never used, and in general, is there a pattern? Do you have some times a day where people use public chargers more than on other times? We have no idea about that. And also the different operators of charging stations are not really open with their data, so they don't give you that information. And of course, the picture about e-mobility is not complete without looking at the place where charging happens most often. And this is, in general, in Switzerland, underground parking. If you have a parking spot in an underground parking space, you usually park your car there during the night, and then it's very convenient to have your charging station also on that parking space, because then you save those trips to a fueling station or a public charging station. Your car is just always filled up in the morning, which is very, very convenient. And we, as EKZ, we strongly believe that this is going to be where 90% of the charging happens. So with that, we have launched a product where we do some billing, we install the charging stations, offer a complete service package. And this also gives us a big advantage. We also know how people charge their cars, and we know how different cars behave. So we don't really know it because we did not analyze the data, but that's why we are here today. And I would be very happy if you could find some nice correlations, maybe even between those private charging points and public ones. Okay. Thank you.
Okay. Thanks. I guess I should stand here. My name is Xu Qianyan. I come from the Energy Science Center of ETH Zurich. And today we bring two challenges. And the first one, as you see here, is energy data visualization. So energy data is complex. They have different shapes. Here we have time series, spatial distribution, and some technical parameters. And we at Energy Science Center have developed a visualization tool to interactively present these results. However, we have different problems regarding different shapes of data. For example, for the time series, the user sometimes want to stack the lines, sometimes not. Sometimes they want to plot different technologies on one plot, sometimes they want to plot different data of different years on one plot. And we also have to adapt the colors according to what the user has selected to plot. And similarly for the spatial distribution data, can we plot multiple technologies on one map? And for the technical parameter, can the user simply move around their mouse and see the technical details of each node, of each transmission line, and so on? So, of course, in these 2 minutes, I can't touch all the details of the problems that we have, but I would suggest that if you are interested in visualization topic, come to talk to me and I will tell you more in detail what we have done so far and what problems we have, and then you choose to focus on one or two of them and tackle them in these 2 days. So what we will provide is our full knowledge and help and flexibility to choose a topic and clearly define questions for each of them and clean and structured data, also established framework. So far you see here our current framework is based on Python, Plotly, and CSV, but this is not restrictive. You work on top of it only if you want. Also, you have the opportunity to see your idea in production very soon because this visualization tool is right now under development and it will be put online very quickly if your idea is promising. And the second challenge we bring today is using machine learning techniques to achieve energy discovery in knowledge discovery from energy data. What does it mean? So energy data does not only have multiple shapes, it also have multiple dimensions. So here is an example of a production profile of 1 week, of 1 year, of one scenario. And if you look at another week in the same year, it's like this. If you look at the same week of another year, it looks like this. And if you look at another scenario, it's again a different picture. So where are the most surprising changes? Can you find it through some data mining or machine learning techniques? So we will again provide our full knowledge and help, clean and structured data, and also opportunity to see your idea in production in an ongoing project, also maybe a thesis if you would like to. And we expect your creativity, of course, and maybe some little bit background in data mining and stuff. So the framework is also done in Python and the data is stored in CSV, but again, it's not restrictive. Just come to talk to me if you are interested in one or two of the challenges that we bring. Thanks.
So I learned I have to stay here. I hope you can hear me. Great. My name is Holger. Okay, we are in an English audience here. You can also call me Howie for those people which are not able to pronounce Holger correctly. And I would like to present you a challenge, which my colleague, that is Philip there, there's a look in that direction, yeah, and myself, we want to present you one. This is an open mind challenge, I would call it, because we don't have a precise aim. The only thing what we have is we have data. And the data comes from smart meters. And the usual application, what the people do with smart meters is, yeah, come on, they do accounting, billing, send you the bill at the end of the year or the month, depending on the thing. But you can do so much more about that. So for example, you can use it for the customer segmentation. If you have a mobile, then you can choose which kind of plan you want to use for your mobile. Do you have also the same opportunity for your energy provider? No, because they don't know you, because they don't know which customers you are. They can probably offer you special tariffs. This is only one idea. So this is this kind of data offers you a lot of different things, what you can do additionally with that. And that is what we would like to aim in this challenge, to find out what could be a nice another application to do with smart meters. Why we should do that? Because you have heard it several times in the other challenges as well. Over, in a couple of years, so let's say in 8 years, we have a lot of smart meters there. And then we can have a lot of different business ideas with that as well. Okay, I hope you enjoy that, and we will see you later. It's not mine.
So, hello everyone. Can anyone tell me what renewable energy source produces the lowest CO2 emissions over the entire lifetime? Someone who hasn't talked to me today. Wind energy. Can anyone tell me what the #1 installed capacity is of in the EU of electricity? Wind energy. It's true. My name's Sarah Barber. I lead the wind energy program at the University of Applied Sciences, Rapperswil. I'm very keen on wind energy. I would like to present my challenge here. So this challenge is to develop a machine learning algorithm to improve site-specific power curve prediction accuracy. So if you buy a wind turbine, you get this lovely theoretical curve. It's not really real. A real power curve looks like this. It's extremely site dependent. What does site dependent mean? It means there's turbulence intensity, there is shear, which is the increase in wind speed with the height. These are all affecting the power by up to around 10%. A high accuracy of this prediction is important for planning, for operation, for trading. And the current methods using this theoretical power curve are just not accurate enough. And so machine learning has a potential to improve these predictions. The relationships are non-linear and non-analytical. And so what the challenge is I've produced a set of 8,000 simulation data sets, so 10-minute averaged wind speed, wind shear, turbulence intensity, and power, and tip deflection, just for fun. And the idea is to develop machine learning algorithms to improve the prediction compared to the standard power curve method. Simulations are being done using a multi-physics tool. If you get a long way on this, I can give you some more data, some real data. In wind energy, there's not very much data available. This is a different topic, which I'd love to talk to people about, open data, especially you. Thank you. Looking forward to working together with you.
Oh yes, I know what happened. Sorry.
Ja, ich sage etwas. Okay, yeah, I'm on. Yeah, now I also have to step in for a colleague, which should have been here to present this challenge, but now I'm here again, and I will also be the challenge owner for the next 2 days. It's about performance gap, and performance gaps are existing on a larger scale and on a smaller scale. So in a building, you have installations, you have many different components which have to work together, and usually they don't fit very well, or let's say they are planned in a good way, but then they perform differently, and they do not play together in a way which is optimal. And probably also the users play a role in that, and fluctuating weathers. So the challenge would be to see first to find good data which are around. We can also provide data from the last year of the building sectors, or of buildings, how they perform energy consumption. You can also play around with photovoltaics, with different installations, heat pumps, etc., just to see how buildings are working or not. Because the Minergie standard, as we use it in Switzerland, this is a planning standard. It's not a standard which is controlling performance in the end. There is the 2000 Watt Society regulations, which are doing it a little bit differently. So they have a planning, and also when you switch on the whole installations, and then you're controlling it and you readjust it. But this is not something which is done on a broad basis. So we would like to see a tool which allows to investigate and to show where the performance gap is, and probably also give some advice how to readjust it or what to do that the whole system is working regularly and also efficiently. This is the performance gap. Okay. Thank you.
So this challenge is being presented remotely. So Oleg is the master of ceremony there.
Everyone, maybe just do kind of like a 10-second stretch. Everyone get up. We don't be sitting on our butts. Take me just a second, but please feel free to move around. You've been doing great so far.
So, can I share my screen here?
Yes, you can, absolutely. We're just going to switch you to the big sound system, and then you can...
Okay, wait a sec. Where to share my screen?
You can click on the bottom left. There's a little...
Oh, yes, yes, yes.
But maybe just start sharing after you've said a few words about yourself.
Okay. Oh.
Great. Looks great, yeah.
Okay. Stop sharing.
All right. We just told everyone to get up and stretch. All right, everybody, stretch time is over. Just give him 10 more seconds. And you're on.
Okay, so hello everyone. I'm a scientist. My name is Xiaojing Zhang from PSI. I'm working for the Laboratory of Energy System Analysis. Today I'm gonna pitch the project idea that I have to figure out where is it the best to install our solar PV. So I hope you can see my screen now. So basically, the idea is very simple. So we all know that in Switzerland, there is some potential estimate for PV potential in Switzerland. For instance, one of the most recent one is from BFE, which gives us the figure of 50 terawatt hours per year for Switzerland. If you know about the Swiss electricity consumption per year, which is about 60 terawatt hours, that is a huge number. But the idea of this project is that we want to take into account some of the more realistic factors from the bottom-up perspective. For instance, we can consider the local, the regional, or the location-specific greenhouse gas emissions in every location in Switzerland based on the electricity mix from Stromkennzeichnung website, and then of course we know what is the greenhouse gas emission for different electricity generation technologies, and based on this we can just calculate what is the life cycle greenhouse gas emissions per kilowatt hour of electricity supply from the grid, and then we can compare that with the individual greenhouse gas emissions that is associated with the single solar PV system that is installed on our rooftop. And another perspective is that we can look at the life cycle cost. So in Switzerland, we have solar PV installed in different sizes, and of course this investment cost is decreasing gradually now and in the future, so we can take into that account, and also consider the location specific tariff that is available in provided in every utility providers, and then we can compare that with the grid supply electricity tariff, and think about whether it makes sense for me to install solar PV. And actually we had already discussed this project concept back in March, but unfortunately it was canceled due to COVID. But then we have also refined this project concept a little bit. One of the most important refinement we have done is to better estimate the potential, take into account those location-specific factors. For instance, how do we differentiate old and new system? Because obviously there is some efficiency difference for the old system. Well, we were in the range of 15% for module efficiency, but nowadays you can easily buy module PV modules with higher efficiency, like 17% or even 20%. And of course, we also aware that there is local network restriction, which is probably not taken into account in the past estimates. So we are in the idea that we can either we can take into account this upgrade of local network into cost account, and also if we cannot upgrade it, then we should probably lower the generation potential we have estimated. And the other thing is we also want to take into account the self-consumption, and here by self-consumption I really mean that we want to take into account the demand we have in mind. For instance, I was hiking in a mountain in Bern just a couple months ago, and here is exactly a roof that you see like a teeny tiny solar PV installed on top, but then you can see in the tool that we have, like Sonanda, this is fully the roof area is fully estimated in terms of calculating the potential. And on top of all this, we want to consider, of course, the PV cost development and also module efficiency development in the future, so that we can have a better understanding of this potential that can be used in the the two perspectives that I just presented in life cycle cost and also life cycle greenhouse gas emissions. So here is some question we can think about to answer. One is from the countrywide perspective, how much potential do we have for Switzerland, and taking into account some of the realistic factors? And then for individual resident, we can try to answer, does it make sense for me to install PV, taking into cost and emissions of my PV system? And also the other interesting question is, how can I find residents around me with similar conditions or interests to reduce the system investment cost? Because we also know that there is this economy of scale. So a larger PV system that you would like to install, probably the lower cost you will get. So basically, we are looking for GIS expert and application UI developer or energy consultant or experts from local utilities and governments, especially those who work on the PV system rollout and implementation plan. So welcome to join our channel and also take a look at our project website. And we also would like to hear more of your thoughts. Thank you.
Thanks very much, Xiaojin. I'll just sweep around so you can see everyone here. And we do have
a lot
quite
of people.
Yeah.
I'll be on Slack.
Exactly, yes. We have quite a few people following the live streams, and we're posting all the challenges to Slack where virtual participation is happening.
Cool.
See you later.
See you.
So.
Switch back there. Okay, stop. Sorry. Now? Yes. So this one is so.
Yeah, skip through.
So here, now we have another type of virtual interaction, which is this is the film. Sorry.
I need to switch to my output.
But we can maybe try. It works. Let's try maybe what I saw first.
Yeah, we'll just use it with your loudspeaker and we can put the microphone next to it. Can you full screen? It was working.
It was working before, right?
Mm-hmm. There we go.
That's working.
Mm-hmm. Just put the microphone onto the laptop.
Sure.
Mm-hmm. Go. Yeah.
Methodology looks really interesting. I agree. This might be a promising case to be applied for the case of Switzerland. What do you think? Absolutely. We could launch it at the hackathon. It's a challenge. As a challenge. That's a great idea. Let's do it. There's so many bright minds outside that can easily be implemented. Do you like to work on a pioneering project that is directly applicable for Switzerland? Are you curious to know how your actions influence your personal carbon footprint? And would you like to have policymakers such as us to have powerful tools at hand to optimize our policy design? If your answer is yes, then help us to put Switzerland on the electricity map. The electricity map is an awesome open source project that shows the real-time CO2 intensity for electricity consumption and production. Until today, Switzerland does not appear on that map. So help us to improve transparency and put Switzerland on that map.
Mr. Heyman is also, as of today, at this point, he's just in the call. So as soon as he's back from the call, you can also raise questions if it comes to the challenge. It was just a video challenge, but don't be afraid that he's at the spot and also to answer the questions.
And now it's your turn.
Okay. Done. Also, welcome from my side. In addition to the just shown challenge provided by the Federal Ministry or Federal Office of Energy, I also want to introduce you my challenge, which is dealing with tomorrow. Tomorrow is the host of the electricity map. But in addition to the electricity map, tomorrow also launched the North app. And what is the North app? The North app is actually an open source app that automatically calculates the carbon footprint to other services and apps. And it's translating activities from these apps and activities to greenhouse gas emissions. So the challenge is how can we contribute to the national targets via visualization, gamification. It gives an interface which allows us to bring in, for example, mobility providers such as SBB or Post Auto or any other activities, and we can launch it on the North app, bring in Switzerland actually in the open source region, in the open source community, and launch also those topics on the nationwide. That's it from my side. Thank you very much.
That's okay. I'll speak now. No, I can speak. I'm sure that everyone can hear me. You're quick. No, I want you to. I prefer not to use it because lots of other people have used it already. Yeah. Okay, you really must be loud. Yeah, I will be loud. Don't worry. As number 13, I'm a little concerned about reusing the microphone. I hope everyone can hear me okay. My name's Ben Bowler. I'm a Senior Research Associate at Lucerne University of Applied Sciences and Arts. And today I would like to bring a challenge called Distributed Analytics for Asset Management. And we're bringing this with an industrial partner that we've got at the university called VIA.
to allow us to analyze that data without centralizing it. The system's quite interesting. It means that the analyst is actually separated from the data, and TAC does the translation. The system does the translation. So data can stay where it is. It can stay at the utility, but it means that we can analyze it to solve the problems. So within the challenge, and I forgive you for not going through the slides, these are an old set of slides, so I don't have the pictures that I was hoping to. But within the challenge, we have access to a number of large transformer data sets, and we will develop an AI-based tool for asset management. The data and security is maintained. The data security is maintained using this system of federated analytics and the system provided by VIA. And what we want to look at is whether it's possible to integrate EV, PV, temperatures, and so on into the analysis as well. You have an opportunity, there are two roles. One is as an analyst to support modeling, help us to develop the models. We're also very interested to talk to utilities who can help us steer our results, who can provide test data, who can help us create a tool which is really going to be useful for analysts and for utilities within Switzerland. Thank you very much.
Ask a question.
Yes.
You speak about the way you expect the AI to manage the asset management.
Mm-hmm.
Tell us a little bit more, because asset managers is massive on the list of things.
Yes, yeah. So we're focusing on transformer asset management. So we've got large transformer databases. We're looking at, in particular, the health index of the transformer. We're looking at how the health index will change over time. So we're going to look at different transformers, different degradation of that health index over time. Then we're going to look at the underlying performance, the underlying drivers of that health index. So looking in particular at the dissolved gas analysis within the transformer to understand how the dissolved gas changes over time, and to look at how we could predict for a given transformer under test, how we could predict how that transformer would decay over time, given its fingerprint, given its characteristics. So we've got access to a large amount of gas data. We've got access to a large amount of this health index, health indice data, and we want to plot heat maps and understand that data, put together probably an artificial neural network to be able to help us predict that.
And the last challenge, so we had lots of data actually, is the anomaly detection in smart meter data.
Hello, my name is Portia Murray. I'm a data analysis engineer at a startup in Zurich that's called Klima, stands for Clean Energy Mapping. And just briefly, we specialize in our sensors which measure electricity consumption at high frequency, our cloud platform which collects this data, and then our machine learning load disaggregation technology, which we apply to this data. So the challenge that we have for you today is essentially, it's quite simple. It's from the smart meter data that we're all collecting, we essentially want to detect when abnormalities are happening in this data. So we've given a data set where we've been collecting data for a particular user over many, many months. We want to detect what is normal behavior and what is not normal behavior. Now, these peaks can come through user behavior changes or poorly performing equipment or human behavior, humans behaving erratically. And essentially, we want to set up alarms so that people can detect when in their businesses or homes they're using abnormally high amounts of energy so that they can change their behavior. So this is a machine learning problem, and I had another slide that's not here. Yeah, there was a
slide missing.
Yeah, exactly.
Oops. Somewhere else.
Okay, great. So essentially the problem is for this hints for implementation, there's many different machine learning algorithms that are applicable for this sort of problem. So it's up to you to choose. I've also tackled this problem myself, so I would be happy to discuss with you about different algorithms that you may choose to use. Preferably these flags should not only be for high energy consumption, which obviously has applications for demand side management, but also potentially also for low energy consumption, which sometimes has applications for users that are elderly or disabled. Perhaps it flags that there's abnormal conditions happening in a certain home, and that's it could flag family members if something was happening. And hints for implementation, essentially this should be able to predict abnormalities after about 3 months of training data, and we recommend something using intervals lower than 15 minutes for the learning for this. So it should also be applicable, not just for homes, but also potentially for industries, small businesses, things like that, and suitable for applications in real time. But obviously, you can feel free to make the challenge your own if you do choose to do this. I would be happy to discuss with you about what we've done so far on this topic. And yeah, feel free to approach me if you find this interesting. Okay, thank you.
For my hair, I have a special treatment.
You've got a special one for special hair.
Special hair, special treatment. And do I have to, does it work?
Yeah.
Yeah, great. So this was the last challenge of our great and quite technical series of challenges. It's very ambitious, I find. Oh, sorry, I have to get back here. Not too much, just there. So now you're gonna have the possibility to choose from these challenges. Let me put back the image where all the challenges are listed. Sorry. Here. Exactly. So these are the numbers of the 15 actually challenges. And each challenge owner is getting a little number and well, the number of their challenge, and you should get to the person. And then I think you will have to choose for a place to install your group. Of course, some challenges might also split into different groups. We advise you not to, I mean, a group of 8 is too much. A group of 5 is kind of good. So if you reach too big sizes, kind of split groups. And first come, first served with the placing. So we will reorganize the room and you can use the rooms upstairs.